All right, ladies and gentlemen, now what we're going to do is we're going to focus solely on the sampling distribution of p hat. So we're going to talk about proportions now. Whenever you are asked to describe the sampling distribution of any statistic, truly, it doesn't have to be p hat x bar. What you're looking for is, I'm thinking, hey, describing a distribution. Anytime we describe something, guys, you're thinking about socks or suds. Now we have one variable, so we're dealing with socks. We learned this way back in September. S stands for the shape, and the shape of a sampling distribution for a statistic is going to be symmetric. Okay. O stands for outliers. We're not going to deal with that. You don't even have to say anything. Okay. In fact, I'm going to do this. I'm going to exit out. Okay. The center of that symmetric distribution, that's going to be your parameter. Okay. So in this case, our parameter is going to be P, the true proportion, whatever's describing that population. Okay. And then finally our S is going to be our standard deviation. And forgive me, guys, when we talk about that center, that parameter, we're essentially talking about the mean. The mean, we assume that the mean is the parameter, okay? And then finally, the standard deviation, this is a formula that I want you to write down, and in class, I'll show you where it is on your formula sheet as well. But to figure out that formula, guys, what we do is we're gonna take P, so that's our parameter, times 1 minus P, divided by N, our sample size. This is our standard deviation for our sampling distribution for P hat. And what we're doing, guys, is we're building a model, okay? And we're gonna be drawing a picture of that model. A model for the sampling distribution of a statistic, okay? It's symmetric, where P will be in our center, our mean, and then we have our standard deviation right here, which I will not write again. That's just that formula right there. And what's going to happen then is we're going to have an observation. We're going to have something that happens. And based off the model, we're going to find the probability of that happening, just like we did with that simulation in video number 1. Okay. And we can do all this. Okay. We can describe the sampling distribution. We can draw conclusions as long as the conditions are met. Okay. We've talked briefly about conditions, but that idea of conditions is that same when I talked about when I was 17 and I had to go to the Plymouth Man down the road and I had to show my ID in order to get into a video or into a movie that was rated R, that I was 17. That was the condition in order to go to the movie. Okay. We have some conditions in order to actually use this sampling distribution for P hat and draw conclusions off of it. And this is our first introduction into this acronym where I say, hey guys, we're not going on a run, we're going on a RIN. Okay. Okay, we're going to use RIN the rest of the semester. What does R stand for? R stands for we need a random sample of size N equals blank. So we just say random sample of N equals 3 or whatever we had. Okay, we always want things to be random, right? That's going to make sure that it's representative of our population. Independence, okay? Independence, ladies and gentlemen, this is key for multiple choice. Please, please, please star this. This independence here is going to allow us to use, this is the condition that allows us to use the standard deviation. If this condition is met, that means we can use this formula here. ID, going to the movie. This condition, use this standard deviation, okay? What is that condition? It's called the 10% rule. And really how it's used is we just say 10 times N, sample size, has to be less than capital N, our population size, okay? And I'll show you how to use that obviously in our next problem. And then finally, our normal condition. On a multiple choice test, if you're asked about how can we use our Z table or our normal CDF in our calculator, this is the normal condition. This allows us to get a Z and then go to our table or to our CDF in our calculator, which I just taught you how to do, okay? And get a p-value. Probability. Okay, so what is this condition? This is where we have to take N, our sample size, times P, our parameter, and that has to be greater than or equal to 10. And then N times 1 minus P has to be greater than or equal to 10. And we have to check both of those, okay? Again, this will be a multiple choice question at some point in your statistical career with us, okay? So make sure you have this highlighted, starred. It will be a multiple choice question. All right, let's go ahead and put this into action now, okay? Only have one kind of problem. This is, if you had me in ninth grade, or 10th grade, I did all my notes this way. And when we do long problems like this, I really, really, really want to encourage you to please, 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 in your notebook, you put the problem, and then the right-hand side, this is where I'm going to be doing the steps. And then the left-hand side, this is where I'm going to be doing the work that's connected to the step, but it's in context of the problem, okay? So we say, records show that 65% of visitors will spend money in the gift shop at a local attraction. If there are 525 visitors on a given day, would you be surprised if at least 70% of these visitors will purchase something? Would we be surprised? Again, we're talking about, is this a likely event or an unlikely event? We're surprised something happens if it's unlikely. If I say the probability it's going to rain tomorrow is 2% and it actually rains tomorrow, you're going to be surprised by that. Okay, that was an unlikely event. This is where we get into the state, plan, do, conclude model as well. So the first thing that I'm going to be looking for is the state. Well, actually, let's rewind. Let's talk about all these numbers first. Records show that 65% of visitors will spend money in the gift shop at a local attraction. 65%. Okay, and then we have a 70%. If there are 525 visitors on a given day, would you be surprised if at least 70% of these visitors will purchase something? Okay, let's actually start with 70%. What is 70% describing? This is what you have to ask yourself. Is it describing the population or is it describing the sample? And this 70%, this is describing the sample of 525 of these visitors right here. So this is my lowercase n. 65%, this is describing all visitors. So 70% is describing the sample. So this right here is our p hat. And this right here, because it's describing the population, all visitors, this is our p. Now the first one is state. What do we want to know? Would we be surprised if at least 70% of these visitors will purchase something? So state, guys, we want a probability statement. Oops. We want to know what is the probability that p hat, and I'll make a little hat over it, is going to be greater than or equal to 0.70. Remember, guys, whenever we're using percentages in math, we always, when we're putting things in the calculator or whatever, it needs to be changed to a decimal, okay? We're wondering if our statistic will be at least 70%. At least is a greater than or equal to. This is our state. So let me do this just to make things nice and organized. Okay, now what we can do is we can build sampling distribution of a statistic model and draw conclusions off of that. But before we can do that, we need to check our conditions, the ones that I just taught you, okay? So for our conditions, we have a random sample, okay? Now notice here, it does not say that we have a random sample. We can assume on these conditions. Unfortunately, I know you're not supposed to assume, but science does assume on things, and they say that, okay? So it doesn't state that it's a random sample, but we're gonna go ahead and we're gonna assume that it is a random sample of 500 visitors. Okay, independent, that's that 10% condition, okay? So 10 times lowercase n has to be less than capital N. Okay, so let's go ahead and do that now. And you don't have to put R random, you could actually just put R. The College Board knows what you're talking about there, as do I. Okay, so we're gonna take 10 times our sample size, which we just put right here, which is nice, 525, is less than, now what I'm gonna do for the population for capital N, I'm just gonna take 525 off and I'm gonna put all there. I'm gonna substitute it for all visitors. And then our normal condition, okay? And just keep in mind, I'll repeat it just in case you weren't listening the first time. This independent condition is gonna allow us to use that standard deviation formula. This normal condition is gonna allow us to get a z-score and find a p-value. That, excuse me, that normal condition is n times p has to be greater than or equal to 10, as well as n times 1 minus p has to be greater than or equal to 10. Okay, so let's do that over here. N is 525, right? Times P. Our P is not 0.7. That's a common mistake, so watch out for that. Our P is 0.65, so 0.65. Again, that's a really common mistake, so just watch out for that. Has to be greater than or equal to 10, and that is true. And then 525 has to be times 1 minus 0.65. Has to be greater than or equal to 10. And that is true as well. Now, some of you are going to be like, Miss Opal, why didn't you put 0.35 there instead of 1 minus? Just get used to me when I teach you guys. I'm always going to plug in the formula just as it says. Because what will happen in my experience, if I would have put 0.35 there, because that is 1 minus 0.65. Okay, sorry guys, it was maybe a little choppy right there. My kids just came in from outside. And so I paused it real quick. So again, I'm not going to calculate this out, even if I can do it in my head, right? And the reason I'm not going to calculate it out is because I always get students that come back to me and they're like, Miss Opal, why did you get 0.35 there? And if I just plug it in as it is in the formula, then I don't get those questions as often. Okay, so our conditions are met, so we can proceed now to actually building this model, this sampling distribution of P hat, okay, of that statistic. Okay, so that comes to our do. So what am I looking for in the do? I'm looking for a picture, okay? That's our model, our sampling distribution of a statistic with our mean, okay? Remember, our mean is our P. So in this case, I always encourage you to identify everything when you're reading it. Our P is 0.65, okay? Our standard deviation, remember that standard deviation is equal to P times 1 minus P. You can probably hear them downstairs, so forgive me if you can hear them, divided by N. Okay, so we have 0.65 times 1 minus 0.65 divided by N, okay? And N is equal to 525. So let's go ahead and let's put that in our calculator right now. I want you to all to do this with me. And the reason I want you to do this is sometimes people make mistakes on how they type it in. I like to kind of encourage you to do it step by step. So do the numerator divided by the denominator and then take the square root of it. I'll show you how I do that. So 0.65 times 1 minus 0.65. Oops. Okay. I'm going to enter. Now I'm going to divide it by 525. And now I'm going to take the square root of that. So in order to do that, you guys, okay, I'm going to hit second. Oops, excuse me, before I do that. Okay, there we go. So second x squared, sorry about that, it's late. Second x squared. And then what I'm going to do is I want this whole answer here in that square root. So I'm going to hit second. And then you see right here, I see this ANS, that's answer. That's my previous answer. I'm going to hit that and hit enter. So that's going to give me the most accurate standard deviation. Rewind that if you didn't know that and I went too fast because I think that's really helpful. So I'm going to go to the fourth decimal place. So 0.0208 is that standard deviation. Okay. Next, what I want to know is I want to know what's my observation. That's my statistic. What did we observe? So that's our P hat in this case. Okay. So our P hat was 70%. And then I'm going to shade to the right because it's a greater than problem. Next, what I want is I want that Z score. Okay, so I know that Z is equal to 0.7 or 0.70, I'll stay consistent, minus 0.65 divided by, again, use those 4 decimal places, 0.0208. Let's go ahead and calculate that. 0.7 minus 0.65 divided by 0.0208, hit enter, and I get 2.40. Again, on a Z-score, you need to only round to the nearest hundredth. That's fine. So 2.40. Now what I'm going to do is I'm going to use that normal CDF, okay? And we talked about on, what was it, Monday and Tuesday, how to do that, okay? And there's notes on that. Go back. If you missed that, go back to that day so you can, go through my slower notes on how to do that. Okay. I'm going to hit second vars. I'm going to go to normal CDF. Okay. My lower bound now is right here. That's 0.7. Oh, excuse me, not 0.7. We're using our z-score. So 2.40, that's my z-score, 4.7. Okay, so 2.40. Okay, my upper is going to be 9999, so way up here. We keep mu as 0 and standard deviation is 1. Now, I know some of you are like, Miss Opal, why can't I just put 0.70999? Mean is 0.65, standard deviation is 0.0208. I don't want you to do that, ladies and gentlemen, because you need to show on the AP test that z-score, okay? You start getting into bad habits of not writing that out. It's not looking good for you on that AP test. That's money in your pocket, okay? So that's why I'm not showing you that, and I don't want you to do it. Okay, so let's go ahead and paste it. Okay, old calculators, you would just put your lower bound, comma, upper bound, comma, 0, comma, 1, hit enter, and we get 0.0082 is our p-value, our probability. 0.00, let me make sure, 82. Hopefully my family can remember that I'm videoing it down here. I don't know if you can remember. Okay, so this is everything from the do, okay, the do. So let's go ahead and let's draw a line here. Okay, what am I going to be grading on a test? I'm just going to be looking for the z-score and the p-value. Again, I really want that picture. I'm going to be disappointed if I don't, but I'm recognizing that some of you, a little higher level of math, you don't necessarily need that. I can't stress enough though, just details. I'm trying to give options for all of you, but just, you know, details. Paying attention to details really can catapult you to the next level. Okay, so that can make all the difference in the world between a score. So I want to encourage you to really make that picture. Finally, we want to conclude. We want to use the question to help you answer in context. So what was the actual question? If there are 525 visitors on a given day, would you be surprised if at least 70% of these visitors will purchase something? Okay. If there are 525 visitors on a given day, the probability that at least 70% of the visitors will purchase something is about 0.0082. Okay. That's the probability. Now, are we surprised by that? This would be surprising if it happened because the probability is so low. We don't have to say it's below 5% or anything yet. We just know anything below 5% is a low probability. All right, ladies and gentlemen, I have one slide left to do. I do want to just let you know that on your homework, you won't always be given p-hat. You may, instead of 70%, you might be given like an actual number and you have to find p-hat. Just a heads up for you on your homework. Okay, there's 1 or 2 questions like that. I'll help you along the way if you need to. The last thing is on multiple choice questions, sometimes what can happen is they may ask you what sample size would be required to reduce the standard deviation of a sampling distribution to 1/2 of the value you found in this question. What about 1/3? Okay, so anytime you want to decrease something by like 1/2, 1/3, I'm just going to go ahead. Usually I do a little discovery with kids. Okay, but what you do, ladies and gentlemen, is you take whatever this number is that they want you to decrease it by. Okay, you're going to find the reciprocal of it. Okay, so the reciprocal is just flipping it. Okay, you're going to square it. So reciprocal squared. And then you're going to multiply it by n, your sample size. So anytime you want to decrease decrease the standard deviation by 1/2 of the value, you would take, well, the reciprocal, that's 2 squared 4 times n, whatever that n is. You want to decrease it by 1/3, take the reciprocal, that's 3. 3 squared is 9 times n. Oftentimes, this is just like a part B or part C on a free response question. You want to decrease it by 1/4 of the value found in a question. You want to take the reciprocal, that's 4 squared, 16 times n. All right, ladies and gentlemen, we are done. This is our longest video. We're getting to the good stuff, guys. This is stuff I really love, love, love. So I hope you are doing okay, and I'm here for you if you have any questions. Have a great day.